Wahoo. This is what you'll be doing. All right, so for problem 1 and problem 2, see below. So here's problem 1 and problem 2. You need to fit onto one page each the following each of the following times per each of the following. I don't know why that says times. Each of the following per differential equation. Get out of here. Be weird. So you need to find an analytical solution, the qualitative solution, and a numerical solution where you set dt equal to 0.1 and dt set to 0.01. And find the percent error of these compared to the real solution at t equals 1. Okay? And so I provide a sample below, right? And for the projects, you do have to do the following. You need to fit this. You need to do this all onto one page. You do need to type it, right? Please follow the sample below. And here's on the project. So the only thing I'm going to dock you for formatting problems, right? Because I want you to get used to putting stuff into a format that your boss will eventually like, right? I only do it twice. It's only 2 projects. And so I want you to put it exactly into this format, right? Put your name, put it up here, say problem 1, right? You're going to type part 1. This analytical solution, you can write this out by hand, right? That's perfectly fine. And then just paste in a picture into whatever document program you're using. That's fine. If you want to use LaTeX, which I did here, you can use LaTeX. I don't have time to explain LaTeX. And here for the qualitative solution, go ahead and just I'm gonna do this with you right now. I'm gonna do the whole project with you right now for at least the sample one. So here's the steps. I don't think I need to do the analytical solution with you. I think you know how to do separable equations, not every step spelled out. Okay, here I would just use whatever program you're using. I'd use whatever program you're using to in order to produce this. And here, so here, what's my it's 2y minus 1. Hello. And then pick something that well represents it. For here, t equals to from -5 to 5 is fine. And then here we'll start from minus 3 to 10 is fine. All right. And so here you can just take a screenshot of this. Now, when it comes to, you see how I drew a couple for slope fields, I like to have a couple sample solutions drawn, right? I just like to have a couple sample solutions. And then however you do it in your program, you can just copy, you can just take a screenshot. And then here I have, hello, thank you. I have a screenshot I can move and do whatever I want with, right? Okay. So that's how you do the qualitative solution. Just put it in, because the last 15 minutes, I'm going to go through the numerical part with you again. Any questions on the qualitative whatsoever? Just type in a couple sample solutions, cut it out, do that. What I'm using, I posted on Canvas, and so you have that to work with. If you want to use something else, just make sure you can clearly see the slope fields. And here I wrote down what y and t, what the range was. But here, if you have in my little screenshot, if you have it here, like -3 from -5 from 0 to 10, right? From 0 here, you don't need to put this here because it's already on the picture. Okay, so if you just crop it so it has that, you're good to go. Okay. What do I use? It's in Canvas. Let me pull it up on Canvas. Whoop. All right, so slope field plotters. There you go. You just click this link right here. It's under the slope field plotters. Just click this link right here. It brings you to this page, and you download this Java file, and you just need to have Java on your computer. If not, you can use this one. It works okay. And just in here for this one, just do 1 or 2, or at least have a sample solution for me. Okay, and that works fine too. But I find the other one, the little Java applet works the best in my opinion. You use HGP solver, so it's all right here. Okay. All right, so let's do in the last few minutes the qualitative one. Okay. All right, so let's do. I need to open up. What do I need to open? I need to open. Yeah, not this. Woohoo. Let's do it in white. I know I do everything in my personal life in black because I'm a sad, brooding man. All right, so let's open this up. All right, so let me redo this one more time with you guys. And so what you're going to use is Euler method to do this. And so let me just create. I have 2 spreadsheets. Boop. All right, so you're going to have a spreadsheet here, which is going to be the one you turn in. And you're just going to write, time. You're going to write, save myself time. And you're just going to fill that in, right? And here you're going to just say 0. And then you're going to just to save yourself time, you're just going to say this cell, you hit equals. You hit equals and you click one above it. And you just add 0.1. And presto, you just bring this down to 1. Ta-da. For the actual, we know what the actual is, right? And so here it equals. Our actual is going to be equal to exp, which is for an exponent, right, of 2 times t. So you click on the t, plus 1, close, divided by 2. And just drag that down. And so here we have the actual, right? So actually you're just going to type in exactly what you get, right? And just have it compute it for you. Now for Euler's method, you're going to have to create a separate sheet. No, I'm going to need a much bigger one than this. Woohoo! Come on, you. All right, so here you can have a k. You're going to have your xk. You're going to have your yk, and you're going to have your fk. And then here I like to have different things. So I'll have my dt. I have my y naught, and then I have my x naught. And I like to put them off to the side because I don't like hard coding it. So 1, and this will equal. You need this category? Not at all. You can totally skip the k category. That's fine. So this is what step you're on. Your initial condition is going to be equal to this. Your initial, oops, I lied. I'm a liar. I need to put in my value 0, 0. Nope, what's my initial condition? All right, what's my initial condition? 1. It's always 0 and 1. And here we're going to put in our dt to be 0.1. Okay. All right, so now we set this equal to 0. Set this equal to. Now, can you just hard code this? Yeah, that's fine. I'm not worried about it. Okay. So this, what does this equal? Well, our equation for our sample here is 2y minus 1. And so here I'm going to say equal to 2 times the y value minus 1. Okay. Now just drag that all the way down. Here, remember, and then here you're going to type in the Euler's part. So remember, this is equal to this, the step above it, plus whatever my delta x is. But remember, since we do not want delta x to change, you want to preserve row and column, and you do that by putting in dollar signs. That. Oops, I didn't click on delta x, did I? Ta-da! I fixed it. There we go. Then from here, y is equal to, remember what this is equal to, it's equal to the previous one plus how much I changed times, so my rate of change times my time step. But notice I do not want my time step to change, so this stays that. Put that in, grab this, and we scroll it down. Wow. All right, and so here, I hit Command Copy. And so here I'm just going to copy this, and then you're going to hit here. You're going to hit paste. It should say paste formula results. You'll have something like that, and you just put it right there. And so that's how you get this first row right here. Did I do something weird? Hold on. Hold on. Why am I getting strangely good numbers? Something went wrong. Oh, ta-da! 2 times y equals 1. There we go. I was like, that looks too good because I typed it in wrong. There we go. Hold on. There we go. Then we just grab this, copy, go to your original sheet, and paste formula results. There we go. All right, so how are we going to get this one? How do we get this row? Because a lot of people send me emails already. I don't know how to do this because I'm not getting right answers. In order to do this, you're going to have to take this, and we're going to have to extend this out. Let's go. Keep going. To 100. So you're going to need 100 time steps. And then all you have to do, if you set it up correctly, is you just swap your dt from 0.1 to 0.01. Then it takes a second because you're going to just have to grab this cell, copy here. Oh, this first one's 1. The second one, this one, you're going to grab 20 here. You're going to hit copy. You can go here and hit paste. Oops, Z. And then here you're going to grab the 30, hit Command copy. And then for here, paste. And I know the command paste formula results. And so you're going to have to paste in the formula results for the rest of this, okay? And so you do have to do 100 iterations. Now, the reason I made it 100 is for very, very particular purpose. If it was 10, I can almost guarantee at least 20 of you would just do it by hand. Say, I don't need the computer. I don't need to figure out Excel. I'll do it by hand. If I make it 100, I'm pretty sure I'll break almost everyone's will to do it 100 times. Now, if I made it 2,000, it's no different than 100, really. Okay. And so that's how you fill out the sheet. And then percent error is, it's just actual. And then here you just take actual minus calculated divided by actual, and that gives you a percent error. Okay. Multiply by 100%. All right, so let's talk real quick about, for the last 4 minutes, I'm going to talk about problems you might run into. First of all, is this separable? Yes. Are you going to have this recording? Yes, I'm going to have this as a recording. I will have to cut out the 5 seconds I just scrolled through the answer because you can just pause and copy. That'd be bad. I'm not used to being recorded 24/7. So yes, this is separable. Notice here, if you move the 2y over and this over, you can factor it out, and then you'll have some function of something of y and something of x. And notice this is also separable. So both of these you solve by using separating them, right? Okay, can you explain how to solve for y in problem 2 after you get an analysis? So here's the other thing. You might end up with a solution. Let me show you the one other problem you might have. And in fact, let me pull this off. My solution real quick. So let me make it something awful. Let's pretend you get something that looks like ln of y. And this is real important. It might seem like I'm just being crazy for 5 seconds, but let me, y to the 5th plus y equals e to the t minus 3. Let's pretend you have something like this. And for those who've gotten this far, this will look really familiar. Yes, I've changed some things, but not that much, right? And you're like, okay, I get this. What am I supposed to do, right? In fact, let's get to the point before this, right? Let's just say I have c here, plus c, right? It's like, okay, I get this. It's like, this is an explicit form, right? I have zero way of figuring out what the answer is. Well, what you can do here to find out what c is, you can just have Wolfram alpha calculated. I have my initial condition of 1, right? And t is 0. So just let Wolfram alpha calculate what this is. And here I get c is equal to 1, right? In this case, c is equal to 1. And so I can just plug in a 1 here. All right, so c equals 1. This will give me back true. So let's pretend I want to find out what is the value of y for the other time values, right? We'll just have Wolfram alpha calculated. I know what it is when it's 0, right? When it's 0, it should calculate y equals to 1, right? And that's given. Well, when t equals 0.1, I'm going to get a solution roughly equal to this. And what you need to do for the one that you get the implicit answer, you're going to have Wolfram alpha solve it for you and just assume this is the analytical answer. It's a numerical solution, yes, but assume it's the analytical answer because it's using what we do in numerics when we don't know the answer. As we do it for a very, 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 very small time step, and we assume that one's true, and then we test for larger time steps in order to test our theory. Okay, so whatever is here, assume this is true. Okay. So that's fine. And so what do I need? That's fine. Is Excel what I need? Yeah. So use either Excel or Numbers or Google Docs. Any of them work, right? And so for this case, I'm going to grab this number here, whatever this number here, and I'm going to input it I'll input this as my truth for 0.1, right? I'll just copy it over. It takes a second, but you can do it. And then for 0.2, I'll input this as the actual value, whatever I get here for 0.2. Now, granted, this is not the correct answer to number 2, but it looks a lot like it. And what I'm doing here, if you have the correct answer in front of you, you can easily translate it over.